All right, so this is our section 1.7, function operations and composition. So this will only be a one-part section, mainly because the majority of this we've done before in Algebra 2 and even some of it in Algebra 1. So what we're going to be talking about is what are function operations and compositions and how are they used. So we're going to be able to perform operations on functions and how to find compositions of functions. Operations are quite a bit easier than the compositions for most of you. But let's just go through some definitions here. We have the sum. Sometimes you see it like this. It says f plus g of x. And what we're basically saying is we're just adding the two functions, so we can also write that as the f of x plus g of x. And then the difference, sometimes you'll see that written as f minus g of x. And of course, that's going to be the same thing as f of x minus g of x. For the product, we'll see f dot g, or f times g of x, which of course means f of x times g of x. And then of course the quotient will have, you could put g on top, but we're going to do f divided by g of x, and that's the same thing as f of x divided by g of x. So just some terminology and notation that you should be aware of, so that way you know how to apply that. So let's do a few examples here. We have f plus g of x. So in other words, that's the same thing as saying f of x plus g of x. So we just simply add the two functions. We have x squared plus 4x. And I always put them in parentheses just in case. And then our g of x is the square root of x plus 2. And then hopefully you can notice when we rewrite this, we have x squared, I'll mess up there, x squared plus 4x plus the square root of x plus 2. And you should notice there's nothing we can combine here. Sometimes you guys make the mistake of thinking, oh, I can combine this x with the 4x, or I can combine the 2 with something. The square root is something separate. We cannot combine it, so this is as simplified as it gets. So now we have one where we're going to subtract. We're going to do f minus h, which is f of x minus h of x. So we have the quantity x squared plus 4x. I have to go down here, it looks like. Minus our second equation, which is 3x plus 5. And now again, remember you have to subtract the entire thing. So some of you will go through and apply the negative first, and that's fine if you want to do that. Or you could just subtract each term. So 4x minus 3x is 1x. So we still have our x squared. 4x minus 3x is 1x. And then minus the 5, we just have minus 5. So the mistake that a lot of you will make there is you'll forget to minus the 5 at the end. You think that minusing the 3x is enough, but remember we were subtracting 5 as well. This is like 0 minus 5 is negative 5. Okay, so let's do some, let's do the multiplication and division. So we have our f times h. So again, that's the same thing as saying f of x times h of x. So we have two quantities that we're going to multiply together. X squared plus 4x times 3x plus 5. So when we multiply, we FOIL this. We get x squared, whoops, not x squared. We get x squared times 3x is 3x to the third plus 5x squared plus 12x squared plus 20x. Combine our middle terms and we get 3x to the third plus 17x squared plus 20x. As simple as that. So for the next one, this is the same thing as saying h of x divided by f of x. So we have our function h of x on top, so 3x plus 5 on top, and on the bottom we have our x squared plus 4x. And really, the degree on top is smaller than the degree on the bottom. So because this is the case, the only thing we have to check is to see if we could factor anything out and cancel. Here, there's nothing to factor out here. Down here, we could factor out an x, and it would be x and then x on the inside plus 4. But again, there's nothing to cancel on the top then, so we will just leave it like this. So that's the operation of functions. The second part is composition of functions, which again, I know we've done this before, but this is good review because I know a lot of us struggle with this. If you look at this example, we have y equals x minus 3 quantities squared. If you think about it, this right here is a composition of functions, where one of your functions is y equals x minus 3, and then the other function is y equals x squared. Because if you take the x minus 3 and plug it in for x, it turns into a composition of functions like what you see on the left. Okay, that's an example of composition of functions. It is written two different ways. More likely you'll see it like this, but you also need to make sure that you understand that it can be written like this. They call it FOG or GOF. Notice the open circle, that means composite. Okay, F composite G, F of G of X. F of G of X, said the same way no matter what you see. Notice that's not a multiplication sign, that's an open circle, which means compose. So let's look at an example. We have F of G of X. So one thing that we have to realize is that if you work from the right to left, basically what we're saying is we have G of X, and that's what we're going to plug in to our F. Okay, so that's what we're plugging into our F, is the G of X. So if our G of X is x minus 4, we are taking the x minus 4 and we are plugging it in to our x. So that will look like x minus 4 squared. So instead of it being x, it's x minus 4 plus 1. Now, don't forget, do not just do squared on both of these. You have to FOIL this out. This will be x minus 4 times x minus 4. So when you FOIL that out, that ends up being x squared minus 8x plus 16, and then we still have this plus 1 at the end. So the final answer is x squared minus 8x plus 17. So hopefully that makes sense. Okay, what I'd like you to do is I would like you to try this. See what you get when you do this one. Okay, so you're doing g of f of x in the opposite direction. So try that, put your answer in, and see how close you get. So hopefully you got x squared minus 3. Again, you're using your x minus 4 as your function, and we are taking now the x squared plus 1, and that's getting plugged in for x. So that's where you see the parentheses there. Normally it would have been an x, but now we are changing it to x squared plus 1. You know, again, as a little side note, remember what this is really saying is g of, and then instead of f of x, so we could say f of x. But that's the same thing as saying g of, and then instead of putting f of x, we'll actually write what our f of x is, which is x squared plus 1. So we're taking the x squared plus 1 and replacing it with our x up here. Okay? So let's move on to, this is what happens when we're only plugging in a function for a function. When we're actually given numbers, this is actually quite a bit easier. Because if you understand that this is just simply equal to f of g of 2, then what we can do is we can first figure out what g of 2 is. G of 2, plugging in our 2, we get 2 minus 4. That's all g of 2 means, is plug 2 in for this. So 2 minus 4 is equal to negative 2. So if that's equal to negative 2, then instead of putting g of 2, we can now write f of negative 2, because that's what g of 2 is equal to. So now we plug in the negative 2 in for f, and we get negative 2 squared plus 1. So negative 2 squared is 4 plus 1. I'm getting a little ahead of myself here. Is equal to 5. Okay, so again, if you figure out what your g of 2 is first, that will tell you what you're then going to plug in for your f. So why don't you try this one on your own? You have g of f of 3 and see how that turns out. So hopefully you got 6 for your answer. In this case, we have f of 3. So we plug our f of 3, or our 3 in for f. So 3 squared plus 1 is equal to 10. So the f of 3 was equal to 10. And that's what was inside of our composite. So it's g of f of 3, and we just figured out that that was equal to 10, so really we're just trying to figure out what g of 10 is. So we plug 10 in for our x. 10 minus 4 is equal to 6. So hopefully this makes sense. We will obviously be practicing this a little bit in class, so I will see you then.